In this video, we are going to learn about linearity check, time variance, and causality for the following systems. So, with this title, let us go for the first problem, like y of t, which is equals to a into x of t plus b. First, let us check with the linearity. Linearity is like in my previous video, we have discussed the clear structure of linearity, time variance, time invariance, causality, and all the categories of systems. So you can check out that video first. Now come to this video because this is a dedicated problem section for that video. Okay. Now let us take t like x1 to t plus x2 of t. When you do so, you will get here a x1 t plus a x2t, but instead of b, here we are getting 2b. So here should like a x1 of t plus a x2 of t plus b only we need to get at the end, but with this we are getting 2b, means here the homogeneity is missing. Okay, so that's why it is a nonlinear system. Now let us go for the time invariance. In the time invariance, when y is like t minus t naught, which is like a x of t minus t naught only, and remaining rest all will be in the same. So t minus t naught, same thing is matching. There is no any other change. So both are same. So that's why it is a time invariant. So what is causality means? X of t is present term only. See here there is no any future terms, so that's why it is a causal system. Now let us go for the second problem. In the second problem, y of n means it is a discrete time signal, okay, which is equals to n x of n. So when you go for the like linearity, like t x1 plus x2 means n of x1 plus x2, like n x1 plus x2 we will get at the final result. So that's why it is a linear. Now let us go for the time invariance. In the time invariance, y of n is equals to n into x of n, right? When you go for the n minus n naught, here also we will get n minus n naught, here also we will get n minus. Instead of varying in the time, it is varying in the amplitude also, right? So that's why it is a time varying system. Okay, causality means all are present terms only, like for the y of n, x of n only. So that's why it is a causal system. Let us go for the next problem, like y of t is x of minus t. Now when you apply the terms linearity, like t x1 plus x2 means x1 plus x2 into minus t. When you do so, you will get x1 of minus t plus x2 of minus t. Same for the homogeneity, here it is matching, so superposition matches, so that's why it is a linear system. Now let us go for the time invariance. Y of t is x of minus t, right? So y of t minus t naught is x of minus of t minus t naught. When you do so, minus t minus into minus plus t naught. So t minus t naught, which is not equals to the minus t plus t naught, right? So that's why it is a time varying function. Remember just one thing, for the t minus t naught of y, you need to get of t minus t naught. Anything multiplication or constant should same. So when this criteria matches, it's just a time invariance. A part of this, all are other are time varying. Okay. Now causality. Here look carefully. Now let us move for the causality check. So before going to causality check, let us go for some theory. Okay. In this problem, you will get the clear idea of how the causality will be, let us take present input as t naught. For the past input t, which should less than the t naught. Okay, past input t should less than t naught, then it is known as the causal system. If t is greater than the t naught means non-causal. Let us see this theory with our example, where our example is y of t which is equals to x of minus t. Let present input t equals to 1 means y of 1 which is equals to x of minus 1, right? Means present input 1 is greater than the past input minus 1. So till here it is a causal. Okay, now let us interchange. Let t equals to minus 1 means y of minus 1 which is equals to the x of 1. Its present input is 1. The past input is 1 means past input is greater, right? So which means it is not a past input, which is a future input, means present input will depending on the future input, right? So for the causal, it should be either present or past input dependency. If future involves means it is a non-causal, right? So here the present input is depending on the future input. So the past input is minus 1. So for by the criteria we can say the past input is like present input is less than the past input means it is a non-causal. Okay, remember, so this belongs to the system non-causal. Okay. I hope you got the idea on this. Let us go for the one another causality check. Y of n is x n plus 3. Let us put the present input as 0. Then the like past output is becoming 3. Present 0 which is less than the past 3, right? So present input depends on future value. So therefore it is known as the non-causal system. I hope you got the idea on this. If you learned anything in this video, please do a like or support by subscribing. Thank you for watching this.